Hello, everybody. My name is Kojo Aite, and my work is on characterization, source of identification, and then environmental assessment of ambient particulate matter. This work is my PhD work, and I'm under the supervision of Dr. Hughes from the Physics Department, Dr. Denchi from the Chemistry Department, University of Ghana, and as well as Dr. Jampo from GAIC. I think Professor Pope has also touched on the source apportionment with the application of sensors. But my work is looking at source apportionment from the gravimetric point of analysis of particulate matter. This my outline. Now, you all bear with me that air pollution falls directly under the number 3 of the United Nations SDGs, and therefore it needs to be touched on. We talks about good health and then well-being for all. Now, air pollution is one of the biggest environmental threats to human and other forms of life or other life forms, and it's actually classified by the WHO as a silent killer because of the number of lives that it claims each year worldwide. And it's also documented in their report in the year 2021 that it claims about 7 million lives each year worldwide. And in Africa, it takes about 1.1 million lives. Now, here in Ghana, it is also reported by the WHO that it claims about 28,000 lives every year. And this report has been by Ghana's EPA, Clean Air Fund, in their earlier reports. Now, if you have to look at the breakdown of these 28,000 deaths that are caused by air pollution each year, now it means that if we want to divide 28,000 by 12 months to give an idea, it gives 2,333, on the average, people that die each month from air pollution in Ghana. Now, if you further divide this value by 31 days, it tells that each day about 75 persons die out of air pollution in Ghana. Now, if you further divide it by 24 hours, it tells you that every hour we have 3 persons dying out of air pollution. And this should tell us how dire the situation is. And therefore, it's a wake-up call for all to be actually involved in solving this problem of air pollution. Now, we all have heard from Monday the definition of air pollution, which is the presence of toxic compounds in the air that is above certain levels that makes it toxic or gives us or impairs our health. Now, a number of substances cause air pollution. One of them is a particulate matter, which comes in different fractions of PM10, PM2.5, and then PM 1.0. In fact, my work is based on or centered on PM2.5. Now, these pictures depict issues of particulate matter generation from different areas or different places on the planet. The one on the right-hand corner is one that was put forward by our reporter who is here, Mr. Albert Ansan of Ghana News Agency. And that was somewhere in November that talks about air pollution that claims same 28,000 lives each year in Ghana. The one on the left corner up is a report that was put together by the World Bank in the year 2021 that also reported that about 16,000 lives are claimed by this air pollution in Ghana. Now, the one down here at the left bottom is also a report that I picked online that is churned out by EU agency that talks about air pollution claims about 1,200 lives yearly in Nigeria. Now, on the right bottom corner, we see air pollution causes school closure in India, and this is just about 2 months ago, an occurrence that came up in India. So it means that this air pollution is an international issue that's cuts across, and it affects us unequally, and therefore needs urgent attention. Now, particulate matter emanates from 2 different sources. We have the natural sources, which is made up of volcanic eruptions sea salt spray, and as well as harmattan dust. And then the other source is from human activities, normally called the anthropogenic activities. And this can be seen as generating from e-waste sites, from unpaved roads, industrial emissions, use of biomass for cooking, and heating and cooking, and as well as vehicular emissions. Now, this particulate matter is so tiny, in fact, it's so 2.5 particulate matter is so tiny, very invisible to the eye, such that when it is inhaled, it gets deep into our lungs. In fact, it can get as deep as into the alveoli, and it can cause several health issues, which we've heard so many times this week. And these pictures depict air pollution incidences where a mother and a child and then children inhale this polluted air full of this particulate matter. Now, of course, some works have been done earlier, which all point to the fact that they all are about the results obtained are far above WHO targeted level of 15 micrograms per cubic meter, and as well as the Ghana standards of 35 micrograms per cubic meter. Now, then the problem is particulate matter is as a result of usage of this biomass for heating and cooking, open burning, resuspended dust that comes from unpaved surfaces, as well as emissions from tailpipes of vehicles. And these give rise to air pollution, particularly in most cities within the sub-Saharan African countries. This also leads to health impacts, particularly on individuals with chronic conditions, and as well as older people, children, and pregnant women that are mostly affected. Unfortunately, in Ghana, we have a paucity of this comprehensive studies on this PM 2.5, their emission sources, and as well as their concentrations. Therefore, my PhD work sought to fill this knowledge gap. Therefore, I hypothesized that the population of Accra metropolitan area may be exposed to high levels of this particulate matter, which could impair their health, particularly in an area like Accra, where a number of various activities of various human activities generate huge levels of this PM 2.5. Therefore, my aim was to measure, characterize, and apportion sources of this particulate matter at 3 different sites of EPA Ghana's major sampling locations. One was at the St. Joseph's Catholic School at Adabraka, and then another site was the Asuma Police Station, and then the third site, sampling location, was at the University of Ghana's Physics Department. And I think all of us have visited the University of Ghana's Physics Department, where you have the sensors mounted. Specifically, I was to use the Aran-N sampler to sample PM 2.5 to determine their mass concentrations, and then to characterize with the application of an SRF technique, and then to use the PMF statistical tool to apportion sources contributing to the natural and then the anthropogenic PM 2.5 levels, and then to use an enrichment factor to investigate the natural and anthropogenic contributions to this air pollution at the different receptor sites. This is the map of my sampling sites. Now, materials that were used for this research included Teflon filter paper of diameter 47 millimeters, a micro balance desiccator, and the Aran air sampler, and as well as an SRF. Now, in here, in the materials, you could find the unloaded filter paper that was used for the sampling, and then underneath you see a loaded filter paper which was picked up from one of the sampling locations, so it could tell how dirty the air at some locations could be. Now, prior to this sampling, the unloaded filter paper was conditioned in a desiccator for about 24 hours in a temperature and relative humidity control lab, after which the weight was determined using the micro balance, and then securely fitted into the head of the air sampler, and then transported to the various sampling locations. Now, at the sampling locations, these samplers were mounted about 5 meters high above the ground level to be able to sample unobstructed air. Now, prior to the sampling, conditions of weather conditions at the particular time of sampling were also recorded, such as temperature, relative humidity, wind speed, wind direction, the date, and then the sampling time as well. Now, the timer was set off to sample this PM 2.5. Now, the sampling protocols were in accordance with EPA Ghana's protocols, and this was for every 24 hours sampling at an interval of 6 days. And then a total of 323 samples were collected over a 2-year sampling period, started from January 2021 to December 2021, and then January 2022 to December 2022. Now, the air sampler draws air through a particle size classifying unit or inlet at a rate of 16.7 liters per minute, and a cyclone, which is in the air sampler, actually selects this particulate matter of diameter 2.5 microns or less. Now, any particles that is more than, or that is higher or bigger than this 2.5 microns is also released by impaction onto a plate, right? That is slightly greased to receive those unwanted or heavier particles. And also, this plate is greased to reduce particle bounce. Now, after 24 hours of sampling, the sites are visited, and then the air samplers are securely, retrieved with a time elapsed or time for sampling noted, the date, and then the prevailing weather conditions again noted. Now, the head that contains the filter were secured in the Ziploc bag and then transported safely to the labs. Now, the loaded filter papers were carefully retrieved from the heads of these samplers, kept in the desiccator, conditioned for about 24 hours, after which the loaded filter papers were weighed to be able to determine the weight of the PM 2.5 deposited on the filter paper. Now, the weight determined, together with the flow rate and the time of sampling, were used to determine the mass concentration of this PM 2.5. And then the mass concentration determined were also compared with the WHO interim limits and as well as Ghana standards. After that, the SRF technique was also applied to this sampled PM 2.5 to be able to determine the elemental concentrations. And I must add that the SRF technique was chosen, among others, because of its non-destructive nature. Sample preparation is very limited or very less, and as well as one can be able to reuse the samples after the SRF analysis. Now, the elemental concentrations obtained after the SRF analysis, together with the mass concentration determined from the particulate matter, were both fed into the PMF statistical model to be able to determine the sources and then their contributions. Now, an enrichment factor analysis was also embarked upon to be able to tell whether human activities or influences from human activities could add to this PM 2.5 sampled. Now, these pictures depict the different sampling sites. Of course, I've said this earlier, so I'll go fast about it. With respect to the sample analysis, with respect to the gravimetric determination to be able to determine the mass concentration of the PM 2.5 sampled. And then with respect to the data analysis, in fact, I will skip the enrichment factor part because this work is an ongoing project which needs to be completed soon. So the enrichment factor analysis have not been executed because some data from one of the sampling locations have not been fully processed.